question because obviously we've been thinking about this whole MH370. You know, sometimes, obviously, like everything else, sometimes science will merge with tragedy. I'm sure you are old enough to have experienced Apollo 1, Challenger, and Columbia.
Right.
What were those like? I mean, I'm somewhat old enough to remember Columbia.
They were well, I remember the was it Columbia was the first one, I think.
No.
Challenger. I remember I was in the middle of taping a TV show, and they stopped taping. They just stopped. What happens? Doing Newton's Apple, and then I went into the control room, and they were watching, Challenger, and everything just stopped, and it was a tremendous tragedy, But then again, what caused it? The real story was what caused it later, and the investigation is really interesting. Because the guy who figured out what caused it was Richard Feynman, a physicist. They wanted to create a panel of experts who would come on. A lot of them were politicians. A lot of them were, but Richard Feynman was, if you want to know anything, one of the greatest minds of our time. And his videos are great. He teaches physics. He talks about physics on a lot of BBC videos and videos that are on YouTube. He said, again, let's collect the facts. Let's go right to the science of the facts, what happened. And no one could figure out what happened that morning, but he knew one thing, is that it was below freezing on the launch pad. And in a classic Feynman lecture, he took a glass of ice water that was on the podium, and he had a sample of the rubber used in the gasket.
The O-ring.
On the O-ring, and he stuck it in the water in front of all the national television, and he said, I did this at home first. I did it at home, and you stick the ice in the water, and look, it loses its resiliency. Now, if this was the temperature and this the circumstances, then those O-rings should never, they should never have launched at that time, because the O-rings lost all their resiliency.
And I actually read that this was going on from like the second space shuttle flight, because I actually looked this up. This was an issue that started from like the second space shuttle flight. You had there was one incident about a year before Challenger where Discovery almost got destroyed because of an O-ring issue.
Well, you understand that there's politics in science. There's a lot of politics in science. A lot of decisions get made for political reasons. If you're gonna scrub a mission that's sitting on the launch pad, it's going to cost you a lot of money. It's very expensive to have to rewind this thing and start it over again.
May I interrupt for a minute? I wanted to make sure that everybody knows that we have the provost here, Dr. Meletius, has just dropped in, and that means we have two chemists aboard, Dr. Chakravarti and Dr. Meletius. And I wonder if you wanted to throw any comment in, now that we have our science journalist as our guest, in the world of chemistry, or mix that with education. I can let you mull that over for a moment if you wish. But thank you for coming. I appreciate it, both of you.
Thank you.
Gentlemen, thank you. If you want to throw in a comment, I'll hit the pause button for a minute. Otherwise, we can open it right back up to the students again. Gentlemen? Okay. So, back row. I'm not gonna get personal or anything, but we wrote one article so far, and the next article is coming up soon, and I have one space writer, so Laura Farrell's going to kill me for picking her out, but we sat and read her article from first draft to second, and she had this amazing story that I'm not sure how you came across it. You can tell that as part of the story, about some of the oldest stars, and they contain the least metal, right? The least metal. So how did you come across that? I want to use Ira as a sounding board. What gave you the first idea about that? Because I didn't ask you about that when we were doing our edits together.
Right. Well, to be quite honest, I did find it originally in the New York Times,